So hi everyone, welcome back to Small Engine Tutorial. It's been 7 months since my last proper repair video. So I have this request from someone who's watching our YouTube channel on the Dolmar. This is a LT-250 which I previously repaired. It's about 4 years ago, or it's almost 5 years by August. So he asked, where can I find the part 2 of this video? As mentioned, I am very keen to see the carby rebuild and coil testing. I have had my Dolmar for 27 years. It is a great piece of machinery. Dolmar is now under Makita brand family, by the way. So I have promised that I'm going to show how to rebuild this carburetor and test the ignition system or ignition coil. So unfortunately, when my last repair of this unit, actually I snapped the front of this one on the clutch, so it's not fixable anymore. But I'll try to show you how to test the coil and rebuild the carburetor, despite of this unit is beyond repair. Anyway, so let's get started. Okay, let's open this one. And also this part here. Also, in order to access the ignition coil, we need to remove this front shaft. There's two screw in the front. This one in the other side. So hopefully we could remove the front. So much rust. Now we have the head, so we could remove this front here. There's another screw on the other side. This one on the bottom. Okay. So we have all the bits and pieces pulled apart. We have the fuel tank. This is what happened before. Why I didn't continue this one? Because I snapped this part here. So there is still rotating, but oh, what is this? Wow, this scares me. It's not a redback. I'm not sure what it is. I think I have to let it go. So I let the spider go. Go to the other side. Go, 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 go. Go, go. Okay. I think it's gone. Okay. Okay, first I'm going to show you how to test ignition. Now grab your multimeter and set your multimeter to at least more than times 20k range of the resistance reading. So I set my multimeter to 20k range because most of the reading it reads around 10k. So you were testing the resistance reading between the chassis or the body of the engine. So this one here is also the body of the engine, the same reference point to the ignition lead, the center of the ignition lead. So between this center here and the body of the engine. So I'm getting around, it's fluctuating, and that's because of the resistance or the corrosion on the contact. Let's fix this one in one point to make sure that we have contact here, we have contact, and on the ignition lead we should get roughly around 10k. It ranges from 10k, 12, yeah, 15, that's fine. So I don't have a really good contact. It seems like, because in the previous video for the last 4 years I did on this one, I did test on the ignition and there's no spark. Or maybe I didn't test, but I test the spark, there's no spark. So I was concluded that there's a problem of ignition. Now we can see that there's intermittent contact between the ignition lead and the carburetor or the engine body. So that indicates that the ignition coil seems good, but we still need to test another point, another terminal to make sure that it's working, it's good. So let me try to pull this one out. Okay, good. Okay, don't worry about this one, we could fix the one easily. So we tested from this point here. Okay, so it's working. We have 12, around 12k. So this is ideal. Around 10k is fine. So we get 12k. So if you read 12 to 15k or 9 to 15k, your ignition coil on the high voltage lead is okay. But we still need to test the kill switch. The kill switch is this wire here. There's two wires. One is the ignition going to the spark plug. One is the kill switch. And the kill switch is used to stop the engine or stop the spark. So the kill switch is connected to this one. So to kill the spark or to kill the engine, we just need to ground this part of the wire here to the body of the engine. So this another wire here, which is connected to the chassis of the engine, which is this two is connected to the switch. So when you turn on the switch or you short the switch, it turns off the engine. So just like that. So what I'm going to do is to test this kill switch or this this wire here. When testing this wire, you set your multimeter to very minimum. At least I set it to 200 ohms range, or depends on your multimeter because this one reads a point 0.1 or like short circuit. So I'll test this one and you should read like 0 ohm. I have 4.4. So you just reference your meter. What's your minimum reading? So you have point 0.3. So between the chassis and this one, you still have a little bit of resistance because this is a coil and should gives you a little bit of resistance. So we'll have 2.3 ohms, so which is good. Some coil, some kill switch reads almost zero or almost short circuit, and the only way to test that one is to use an extra function of a multimeter, which most of you doesn't have that functionality. Where my one has inductance reading. So if I set this one to inductance in millihenry, so this inductance here, where's inductance here? This one here, L. So I set this one to mH, which is millihenry. This will read inductance, small inductance of the kill switch. So if you short circuit this one, you have zero. But if you test this one between the chassis of the engine to the kill switch, you will get something. So 2.4 millihenries, 2.5 millihenries, which is good. And for the ignition, if you prefer to test the ignition lead with inductance, you set the inductance to Henry because this is huge. This one is in like around over 100 millihenries or even henries, I think. So if I test this one, because this one is in henries, oh, this is a 9.4. So you will get huge amount of inductance here. So indicates that this is good and a lot of winding. You get the right resistance. Also the expected inductance of around 10 millihenries. Sorry, 10 henries. So this is how you test the ignition. So this ignition coil is good. So I could fix this part here. Okay, I'll try to fix this ignition lead. Um, okay, then we have to insert this one to here. Okay, so I'll try to, if we could remove this bolt here, the broken bolt, and also on one of the shaft. So what I did is I have to place a string or pull cord inside so we could wedge the crankshaft. So so I make a cut on the broken bolt. So we'll see if we could take it out. Oh, doesn't. Also, it doesn't go in. It doesn't come out. Okay, so we managed to take bolt out. So hopefully we could replace this one. So one's out, and also the other side. Okay, so we managed to take this out. So all we need is to find the right size bolt, and we could install this flywheel again. So without the flywheel, we can't test the engine. So I found a temporary fix. I used this tensile bolt. So I just screwed this one here. Once it's tight, then we bolt this one here. So I think that was good enough to keep the flywheel in place. So if we successfully rebuild the carburetor, we can test the engine at least. So I just want to double check to make sure that when the magnet lines up with the coil, we are on the TDC, or top dead center. So this one lines up here. It should be on the very top. So that's lines up. Yeah, that's perfect. Okay. Let's give a good sanding for the magnet on the flywheel. So you don't have to remove the engine to remove the carburetor. So all you need to do is to remove the air filter cover. This one has missing air filter. So just remove the two screws. So just remove the air filter assembly, and with the throttle cable, just simply press this one, and then just release the this cable here. Now you could remove the carburetor, also obviously the fuel lines. Now we have the carburetor. We're going to rebuild this carburetor. Since this engine has been sitting for over 10 years, so we need to fully rebuild the carburetor. So first thing to do is we need to remove the metering side part. So we have here the metering diaphragm. It's it's not good. So you can hear the clicking sound. And also the metering gasket, we need to remove this one. Also needs to replace the metering gasket. So now we have here is the metering lever. You also need to remove this one because we're going to clean it. So you hold the metering lever while removing the screw. Because we have the spring underneath. And we have the needle valve. Now we can separate the base assembly. This is really hard. Okay, so this is the fuel pump diaphragm here. So the one on the top is the fuel pump gasket. The one on the bottom is the fuel pump diaphragm. So we also need to replace this one. They're fused together. So that's the fuel pump diaphragm, and that's the fuel pump gasket. And also we need to remove the nozzle so we could replace the o-ring. So that's the o-ring and the nozzle. Now removing the throttle assembly. So we need to release this one a little bit. so we can access that screw. Now we can remove the throttle assembly. So now we could clean all the parts, including the base assembly.